Hello everyone, my name is Matias Koski, CEO of Immersal. It's great to be here. It's my 4th year in a row and nice to see so many familiar faces. I will speak about spatial computing and especially VPS, so Visual Positioning System, and how it will change the world. Quickly about us. So Immersal, it's 10 years of progress. We have been developing our VPS past 10 years and we got acquired by Hexagon roughly 4 years ago. We have about 20 people as of now, and then we also utilize resources from Hexagon. Hexagon is 25,000 employees, 55 different countries, and basically offices in all the key cities in the world. So let's talk about evolution of spatial computing and then also the revolution of VPS. I will leave a few minutes in the end of the presentation and we can have then like quick Q&A. I also brought in my colleague Mikko Karvonen, who is also one of our co-founders, and he knows all the technical details. So, evolution of spatial computing. There's 4 key phases. I have to admit that I'm so young that I don't recall well about the first phase in 1980s. Then we had these so-called fixed location computers, so laptops and then desktops. And the interaction was mainly done with keyboard and mouses. That was changed by Nokia early 2000 when they started to add cameras and GPS on the mobile phones. And then everyone knows the year when Apple announced the iPhone and the touchscreen. So that changed basically the world of spatial computing. Apps started to understand the real world in 2D format. Everyone knows the blue dot in Google Maps, so it knows exactly where you are within few meters accuracy. The next phase was the AR and VR era. Roughly 2016 started by Oculus, HoloLens, Unreal, you name it. And you were able to map small places like your rooms, maybe some small walls outside of the buildings. And the early phase of VPS started. So the next big thing will be the VPS, so-called city-scale VPS, that will allow robots and humans to interact seamlessly in city scale. That will be the spatial computing era. Real-time 3D understanding for all of the devices which has a camera. So only based on image you can know exactly your position in 3D. This will enable all kind of use cases from AR navigation all the way to last mile deliveries and robots. The world will become a canvas for spatial computing. There's now roughly 15 billion devices in the world that can utilize spatial maps. This includes all the mobile phones and then tablets. And by 2030, the market should be 430 billion USDs. So there will be also plenty of robots on the streets utilizing the spatial maps. For those who don't know what is VPS, so I have done this small short slide about the concept. So you have 3 phases. There's a map, augment, and experience. The first step is that you have to build the spatial map. You take plenty of images from surrounding, you combine them and create so-called spatial map. We as a company call it a 3D feature point cloud. So it's machine readable version of the real world. The next phase is augment. So you can enrich the maps by adding real-time sensor data and real-time 3D content. The final part is of course the experience. So you can start experiencing on these maps and share with your friends. The key criteria is that you have a camera, that you know exactly where you are and how you are holding the device. So quickly about us and what you can do with our tech. So it can be also white labeled. Quite often, especially in Asia and in China, our customers white label our technology. So they want to show to end customers that everything is built in-house. And this is actually quite important in China. It has to be made in China. And we don't mind as long as we get paid for our license. And of course, you can integrate our tech to your existing tech stack. Let's say underground mines in these mission critical conditions. You have to have, let's say, 2 different tech that you can use for tracking and localizing. Or then you can also spin off new experiences or apps and utilize us as a like enabling layer. Our solution is quite easy to deploy and light, so it can be deployed as little as 3 weeks. Like I mentioned, 10 years of progress. Our team started with so-called like a small point of interest maps, like 5 by 5 meters areas, or it can be also facade of building. And for some reason, when we launched our product, suddenly we got like thousands of fans in Japan. And the video on the left is also from Japan, from our early days. Then we expanded to stadiums. One of the public use cases is a few years back from Seattle, when we did a project together with MLB and T-Mobile. The idea was to create a fan experience to showcase what are the advantages of 5G and real-time data. Past 18 months, we have been mainly focusing on big maps, which means that you can map hundreds of kilometers of tunnels or tens of square kilometers of spaces. So oil refineries, underground mines, you name it. And now we are moving to the next chapter. So we are starting mapping the cities, and that will change the way of living going forward. I will show you a short video what we have done in the past few months. Oh, thank you. So, the first city is Helsinki. It's an easy choice for us. The whole team is based in Helsinki, excluding our CTO who sits in Estonia. But we call it like south part of Helsinki. It's so close by. You have all the capital in the world in USA, but we have 4 seasons. and that's really good for our testing. You know, this has to work in 4 seasons. Our winter is bloody cold, but when it's tested in rough conditions, I can guarantee it will work. Next one is San Francisco. It's a capital city of innovations, so we also must be there. And that's why we have chosen San Francisco. Zurich, that will be mapped by end of this week. So as a European company, it's one of the key cities in Europe. And there's all the big tech players around. Then, of course, London, capital city of Europe, I would say, or the key hub. That will be available then in a few months. Chicago, that will be mapped by end of September. The reason why we choose Chicago is that we have a customer there paying all of this fund. And then the end goal for next year is to map the whole world. Some of you might think that how much all of this costs, and I can tell you it's 15,000 USD per city. So for the first 100 cities, it's 1.5 million. And I think that's nothing for the big tech companies. In a modern cities, you can't avoid tunnels. I used to be based in Hong Kong. We had plenty of tunnels in Hong Kong. And that's why we got the idea that, hey, shall we contact mining companies and test that in underground tunnels? And then we managed to close Nordkalk as our first customer. On the video, you can see the camera feed and then also the real-time position, how it's moving. Those videos are not perfectly synced, but I think you get the idea. And I don't like those videos that are kind of like edited and then used AI to look them pretty. So that's why I thought that I will show you some real stuff, and then you get the feeling that bloody hell, it works. Then case Boliden. They heard about our customer Nordkalk, and they also wanted to test this in Nordics. So it's one of the Nordic leading mining companies. And they are using our tech 24/7 to track vehicles and people in their mine. So we have mapped the whole mine. And this is a snapshot from the visualization tool, and then you can also see the camera feed. So again, it's working underground without GPS. Some more information about the stats itself. So you can also recycle your data. So you can have like autonomous vehicles running on the streets, or this is done with one of our customers who has autonomous vehicles in tunnels. On the left, you can see test 1. So out of 2,738 images, we were able to localize 2,691 images. So it's about 99% accuracy. And in this kind of use cases, you don't have to localize every frame, like in AR experience when you have the fancy content, and if it starts to jump, it doesn't look nice. In terms of accuracy, 3.9 centimeters. So is it like roughly less than 2 inches? And the rotation delta is 0.2 degrees. Similar test in the same environment, more or less same results, 4.6 centimeters accuracy, and then also 0.25 degrees delta. And with this accuracy, we can cover 99% of the use cases in underground mines. I know one use case that we can't do, and that's the thing that they are measuring the walls. If they are moving like few millimeters, they have to know exactly where that place it is, and will that tunnel collapse soon. If you can scan it, you can augment it. So there will be several use cases where VPS will be utilized. I have listed a few of those. I know, and we are in talks with some defense customers. There is plenty of use cases, but I think the sales cycle is too long for us that we will not stick on those in the short term. So now we are looking for enterprise partners and use cases. I showed you the cities that will be mapped in coming months. There's still room for new cities in for Q4 this year, so starting from October. If you have some use cases or partners in mind, please ping me. You can see my contact details on the left. And yeah, just ping me an email. That's it. That's kind of like what we have been cooking past few months. And now let's have the Q&A. And I don't know, Mikko, do you want to come in the States or?
Well, if anyone has any question, please come to the mic. We have quite a bit of time.
Okay. Go there.
The city scale stuff you're doing looks like it was just using 360 cameras. Is that presumably done by driving, or were you getting sidewalk view as well?
Only by driving. So we don't have to like map those sidewalks separately.
Any other question?
I've been recently using Immersal. I think it's awesome, by the way. So
thank you.
Really good stuff. But I didn't know that you guys were actually mapping out entire cities. So how does that work? Would that GLB model be available, or will that map model, that data just be available for us developers to be able to use and things like Unity? Like how do you end up distributing that city scale model for availability?
Yeah, the idea is at least now Helsinki and San Francisco will be publicly available, and rest of the cities we have to still define. And for example, Chicago depends about our customer because they will be using the map. So I'm not confident that they kind of like allow us to reshare it.
So let it, yeah, has to be the city that probably uses it, right?
Yes.
Okay, I got it. I might have a city also that might be interested, so I'll be sure to reach out to you. Thank you.
Perfect. Anyone else?
Hi. How do you handle updates to the map? Do you have to be constantly mapping every few weeks? How do you handle things like construction? I'm curious to hear more about that.
Yeah, typically the scan will last about 12 months, depending about the places and how it has been mapped. And then there's different ways of updating the map as well. I think it's a bit classified information.
Yeah, as Matias mentioned, 4 seasons, so we can localize summer images to winter maps with snow, and they still work. But eventually there has to be remapping. But well, we don't have to do it all the time.
Hello, I just missed the first part. So the visual localization that you showed, is it exclusively like 3D map based, or like there's other stuff to it like retrieval? Could you talk a little bit about it?
I guess this is for you, Mikko.
Sorry.
So the visual localization that you've showed so far, is it exclusively 3D map based? Like 2D to 3D that's the way localization is working, or is there something more to it as well?
I'm not sure if I understand the question, but we use images to localize. So we need image from the camera, and the camera intrinsics, and then we can localize the pose in like a 3D coordinates, which can be converted into, for example, in Unity, the local Unity coordinates, but they can also be like global coordinates, latitude, longitude.
Right. So just to follow up on the previous question, if the environment were to change, then the localization, if it's 3D to 2D, it would be severely affected, right? So that's my question, like how did you tackle dynamic effects, and so is there something beyond the 3D map that you reconstructed and using that for the localization of the camera?
I didn't get that.
Okay, I can explain it later if you want.
Yeah, we can have a chat after this. Okay.
Any other questions?
You mentioned these cities. Is this part of a comprehensive program, or where we will be able to access these number of these cities? Or in other words, is it a content program that you'll fill out all the cities of the world? Is that the strategy, or is this something bespoke where it's project based?
Yeah, the idea is that we map first these key cities. We test the demand, and then if there's a demand, we will start mapping all of the key cities around the world, and then we can sublease the maps.
I was just wondering if you could elaborate on that 15K number that you quoted for cities. That was kind of shocking. And I was curious if you could elaborate a little bit on that cost. Anyway.
Yeah, it's mostly coming from the labor costs, because you have to have like feet on the ground, or basically you have to hire a car and then you have to drive the streets. And the good thing for us is that we can map the streets only by driving a car. So we don't have to walk on the sidewalks and also map those separately.
About the city, if mayor office wants to do that, can they use their own labor to drive the cost down, do you think?
Yes, they can do it by themselves.
And if they do that, what do you think the cost would be around? I mean, like a city like San Francisco, of course, you can't say every city, but...
Yeah, it's roughly 50 man days per city.
50?
Yeah, 50 man days per city.
So we experimented with USDK quite a bit last year, and we did notice that it was pretty dependent on having the area they're scanning, capturing all the viewpoints of the area that you want to relocalize.
Mm-hmm.
So I was wondering, how are you able to achieve that then if you're just scanning on the roadway and then the person's on the sidewalk? How is that relocalization happening? Because when we were testing last year, we didn't observe that, but maybe there was some changes that have been made. So if you're just scanning the roadway, how are you relocalizing on the sidewalk from a pedestrian point of view?
Well, this VPS 2.0 city scale is using a completely new technology, ML based, so we can localize better from different angles and viewpoints.
So basically the core tech has changed in the past 6 months, and it's not public available yet for everyone.
Last follow-up question is the San Francisco, you said San Francisco and Helsinki, you will make those data public. Is that public now? Like, could we get the San Francisco if we wanted to do testing there?
Helsinki is public now. Frisco will be public in July.
So San Francisco?
Yeah.
In July?
July, yes.
Thank you.
We still have 5 minutes, so if you guys want to talk about anything else, you still have 5 minutes.
Is there any questions?
I don't know if there's any other question.
If there's time, I would like to elaborate on my question. I will talk to you guys later, but if a city is interested and this, let's say they pay the cost, then the development side, are you also helping them for their application, or can any developer just jump in and do the job, like us, for instance, and just get you do the scanning if they are not interested? That can work that way, right? You can come in and scan, and then we can develop the app for them.
Correct. So we can do the scanning. We provide you the license that you can use our VPS, but then the content has to come from yourself, or then you have to have a partner.
Okay. Thank you.
Do you see any role in neural radiance fields or Gaussian splats in your tech in the future?
You want to comment on that?
Well, maybe for content, but we're not really using that in our localization technology.
Thank you so much. This was a great session. Let's give them a warm round of applause.